Hello everyone, my name is Hugo Perez and I'm the Microsystems Manager at DENSsolutions. With this video, I'd like to give you a quick introduction on how to prepare and transfer lamellas in an easier and a more reliable way. Now, the first thing that I would like to point out is that this method is particularly suitable or useful when your sample has a thickness below 500 nanometers, because that's typically when you would require to induce the platinum deposition, which is where all the problems are mostly coming from. Now, the first thing that you would have to do is find the correct crystal orientation of your sample. You can do this using the EBDS capability of the FIB. And then you will have to place your sample in such orientation in the custom-made stub developed by DENSsolutions. Now, this stub, as you can see, contains a 45 degrees angle on both sides. On one hand, you place your sample. On the other side, you place the nanochip, and then you bring this inside the FIB. Now, as we all know, there will be a 52 degrees angle between the electron beam and the ion beam, and the idea would be to prepare the lamella completely perpendicular to the ion beam. So due to the 45 degrees angle at which the sample is located, you will have to start the process by tilting the stub to 7 degrees. Now, at this moment, you would prepare the lamella as you would normally do. That means inducing the platinum deposition, doing some backside milling, some frontside milling to create the trenches, and then of course to start cutting on the sides of the lamella until you can eventually release it. Of course, after the millings have been made, you will have to do the so-called pre-thinning to bring the thickness of the lamella down to 100 or 200 nanometers, and then you will have to do some over tilting of the stub so that you can do an undercutting before you can think of releasing the lamella. Now, once the lamella is prepared and ready to go, you can introduce the Omni probe, weld it to the lamella, and remove it from the rest of the sample. Now, as you will see in the sketch that is depicted at this moment, the lamella will basically be completely parallel to the nanochip, and that means that the chip will be completely parallel, or the electron transparent window will be completely parallel to the lamella. So this makes the transferring much easier and very robust. Now at this moment, the platinum is facing the ion beam, so as you can see here, you have to rotate the chip 180 degrees so that you can do the final thinning without the problem of dispersing or spreading the platinum. Now at this moment, the final thickness of your lamella can go down to the 20 or 30 nanometers that you would ideally like to end up having, and as you can see, this will result in a slight angle. However, you can compensate for this angle during the tilting capabilities that our holder can offer. So as you could see, you can basically prepare the lamellas without the risk of losing the sample, and you can decrease the amount that is required, the amount of time that is required to prepare it. So if you've got any question, please call us.